I'm very satisfied with our fourth project year. Scientifically, we have a real computer that we have built from the ground up with homemade components and that now works as a computer. It's not a physics experiment anymore. From a management point of view, not only did we have successful project meetings, we've also grown together and achieved, both on the scientific integration side and on the systems engineering side, as well as in the everyday way of working and management, a true, narrow, seamless project cohesion. We have made two kinds of progress towards the 30-qubit demonstrator. On the one hand, we have closed all the gaps in our smaller systems, so now our test users can see where are features in the usability of our system that still need improvement. On the other hand, we have developed our first 30-qubit chips. They have just come out of production, and we will see how good they are when we test them and roll them out early in the next year. For the project's critical path, it was decisive that our software stack for external access came together, but also it was very important that we were able to install some of our processors in an infrastructure that can be used externally, so people can work with it without fine-tuning by people in the lab. It's just a machine that you can use from the outside. It was also important that we are now collecting experience. How does our system work in operation? Is it stable? Is it reliable? Does it have the same performance every day? In terms of hardware and software, a lot of details on our chips have been improved. They have a lot fewer errors. They also got a little bit bigger. We have also perfectioned our readout system, our hardware for getting the data out of the quantum computers. On the hardware side, we have come up with a new gate scheme. We have written new papers. On the side of software, clearly the smoke test of the system has been a big achievement, but we have also rolled out first use cases, for example, for the chemical industry, that we can validate on those quantum computers on the path to quantum usefulness. To integrate the system into our unique infrastructure in Jülich, we had mostly a connection between physicists who made the chips, who built the system from the ground up, and computer scientists, mostly companies, that developed a software stack and a lot of critical components on the area of firmware in between. So multiple components have worked together. They were coordinated by our system integration team. And in the future, more and more consortium partners will contribute to the larger rollouts that we are going to have. In improving qubit coherence and connectivity, we have really focused on the coherence aspect. So there was tremendous progress in fixing many little details in the material. The era of the big breakthroughs that we had in the past is over. Now we are proceeding stepwise with cleaner fabrication processes, with better coupling and decoupling of the qubits. That has helped to improve the performance overall, such that specifically our 2-qubit gate fidelities are compatible with the best in the world. The best in the world have larger chips and larger connectivity, but that's what we try to achieve next year then, by going from a chain connectivity to a 2-step ladder connectivity. Scalability is often framed as only the ability to make a large chip, to make many qubits. But what really counts is that you can use all of them and that your coherence doesn't suffer when you scale up. So our first step at scalability has been to make our qubits really high performing on their own, and also to make sure that when we go to a larger architecture, we are not compromising. That, for example, means that we are avoiding what is called spurious coupling. That is the little physical coupling that you have between qubits that are very distant on a chip, even when they shouldn't couple to each other. So our architecture has a specific property that we can also decouple the qubits if we want to, so we're not compromised as we're getting bigger, and getting bigger based on these elements in almost a copy and paste way. It's certainly not completely copy and paste, is then the goal of year 5.